This video is going to cover Module 6, Homework 1, which is solving equations by factoring. So this whole time we've been factoring equations, and then now we're actually going to solve them. So the first example says solve the equation x plus 5 times 3x minus 4 equals 0. So notice this is already in factored form for us, which is nice. It's already in factored form for us. So if you think about it, if we have two things that are being multiplied together, we have x plus 5 times 3x minus 4, two things that are being multiplied together, and if they equal 0, we have a couple different options. We know the first one can be 0, second one could be whatever it wants. Either way, it's still going to be 0. Likewise, if the first factor is whatever, some number, and our second factor is 0, we know some number times 0 is still going to be 0. Or if they are both 0, so 0 times 0 will still equal 0. So basically, if I know this first factor is equal to 0, then the whole thing is going to be equal to 0. If the second factor is equal to 0, then the whole equation is going to be equal to 0. So meaning I can set each factor equal to 0 and solve them separately. I have two factors. That tells me I'm going to have two answers. So we are going to set each factor equal to 0. And then solve. So one factor is x plus 5. So we have x plus 5 equals 0. Our other factor is 3x minus 4. So we have 3x minus 4 equals 0. So now I have two separate, smaller, simple equations. I can solve each of them separately. So starting off with x plus 5 equals 0. I want to get x equals, I want to get x by itself. So that means I can subtract 5 from both sides. And I will get x equals negative 5 as my first answer. Same thing over here, 3x minus 4 equals 0. To get x by itself, I need to add 4 to both sides. That way negative 4 plus 4 goes to 0, and it cancels out. We're left with 3x equals positive 4. Lastly, dividing both sides by 3. That way 3x divided by 3 will give us 1x, which is just x, equals 4 divided by 3. 4/3 cannot be simplified, so that will be our other answer. So our two answers for this first example are negative 5 and 4/3. So my math lab, or my lab math, it already has the squiggly brackets for you, so it only wants your answers. So negative 5, comma 4/3. That's how you'd put it into my math lab or my lab math. Next example, solve the following equation. C squared plus 9c plus 20 equals 0. Exactly like the previous problem. The only difference now is it's not in factored form. This is in standard form. Which remember is ax squared plus bx plus c equals 0. So only difference with this one is we have to factor it first. Factor it, set each factor equal to 0, and then solve, and that's it. So our first step in factoring, c squared plus 9c plus 20, is to find a GCF. There's nothing that all three terms have in common, so no GCF. Our a value is 1, b is 9, c is 20. So we are looking for two numbers that can be multiplied together to give us a times c. So 1 times 20, which is 20. And the same two numbers that could be added together to give me b, which is 9. So looking at this, 5 times 4 is 20. 5 plus 4 is 9. So 5 and 4 satisfy both conditions. Because a is 1, we can use our little shortcut. and go straight to our factors. If you don't like to use a shortcut, factor by grouping like we do every single time, you'll still get the same answer. But because A is 1, I can go straight to my factors using the numbers in my blanks. So C plus 5 and C plus 4 equals 0. So using the numbers in my blanks, I can go straight to my factors. C plus 5, C plus 4 equals 0. Remember, this only works when A is 1. So now that it's in factored form, I can set each factor equal to 0 and solve each one separately. So we have C plus 5 equals 0, and we have C plus 4 equals 0. Solving each one separately, C plus 5 equals 0. Getting C by itself, I can subtract 5 from both sides, and we are left with C equals -5 as one answer. C plus 4 equals 0. I can subtract 4 from both sides and get our second answer of C equals -4. So our final answers are -5, -4. Next example. All right, this next example asks us to solve the following equation. Z squared plus 7 equals 8z. So first, we had to put this in standard form. This one's not in standard form already for us. So I have to get it set equal to 0. So to do so, I'm going to subtract 8z from both sides to put into standard form, which remember is ax squared plus bx plus c equals 0. So that'll leave us left over with z squared minus 8z plus 7 equals 0. It is now in standard form, so we can now factor. Our first step in factoring is GCF. There's nothing that z squared, -8z, and +7 have in common, so there is no GCF. Our A value is 1, B is -8, and C is +7. So we are looking for two numbers that multiply together to give us A times C, so 1 times 7, which is 7, and the same two numbers to add together to give us B, which is -8. So -1 times -7 is +7. -1 plus -7 is also -8. So -1 and -7 satisfy both conditions. So notice, because our A value is 1, we can use our shortcut and go straight to our factors. So if -1 and -7 fill in our blanks, those are the numbers we're going to use for our factors. So using our variable z, so z minus 1 and z minus 7 will still equal that 0. So because A is 1, we can go straight to our factors of z minus 1 and z minus 7 using the numbers in our blanks. Now that we have it in factored form, we can set each factor equal to 0 and solve each one separately. So z minus 1 equals 0 and z minus 7 equals 0. Solving each one separately, z minus 1 equals 0. I can add 1 to both sides, and I'm left with my first answer of z equals +1. Z minus 7 equals 0. I can add 7 to both sides and get my final answer of z equals 7. So our two answers are 1 and -7. Next example. Solve the following equation. X times 5x plus 9 equals 2. So I still want to put this in standard form first. Which is ax squared plus bx plus c equals 0. So I'm going to start to do that by distributing. So I'm going to distribute that x to both terms. So x times 5x will give us 5x squared. X times 9 will give us plus 9x equals 2. So still trying to get this set equal to 0 to put it into standard form. We're going to subtract 2 from both sides. That way we're left over with 5x squared minus 9x minus 2 equals 0. It's now in standard form, so we can now factor. So 5x squared minus 9x minus 2. Our first step in factoring is GCF, which there's nothing that all three terms have in common, so no GCF. Our a value is 5. Our b value is -9, and our c value is -2. So we are looking for two numbers that can multiply together to give us a times c, so 5 times -2, which is -10. And the same two numbers to add together to give us -9, which is b. So looking at this, -1, I'm sorry, this is supposed to be +9. There we go. So two numbers that will multiply together to give us -10 and add together to give us +9. There we go. I'm sorry. So we have 10 times -1 is -10. 10 plus -1 is +9. So 10 and -1 satisfy both conditions. Here, our a value is 5. So because our a value does not equal 1, we must factor by grouping. So going old school and factoring by grouping. So to do this, our 5x squared is going to stay the same. We are going to split up our middle 9x using the numbers in our blanks. So I have plus 10x minus 1x, and then our -2 equals 0 is going to stay the same. So we now have 5x squared plus 10x minus x minus 2 equals 0. I now have 4 terms, so I can factor by grouping. So grouping the first 2 terms together and the last 2 terms together. Looking at our first 2 terms, 5x squared plus 10x, they both have a 5x in common as a GCF. So we are going to factor or divide out that GCF of 5x from both terms. So 5x, and we're left over with x plus 2. 5x squared divided by 5x, we're left over with 1x. 10x divided by 5x, we're left over with +2. Looking at our next 2 terms, -x minus 2. GCF, they both have that -1 in common. I also know I want to factor out or divide out that -1 because I want +x plus 2 to be left over just like my other factor. So taking out that -1, I am left over with x plus 2 equals 0. -x divided by -1 is +x. -2 divided by -1 is +2. So we now have 5x times x plus 2 minus 1 times x plus 2 equals 0. We know we did it right because they both have a GCF of x plus 2 in common. So that factor is going to come out front. Taking out that x plus 2, we're left over with our other factor of 5x minus 1. So our two factors are x plus 2 and 5x minus 1 equals 0. So last step, we are going to set each factor equal to 0 and solve each one separately. So we have x plus 2 equals 0 and 5x minus 1 equals 0. Solving each one separately, x plus 2 equals 0. I can subtract 2 from both sides. we are left over with our first solution of x equals -2. Our second one, 5x minus 1 equals 0. I can add 1 to both sides. We're left over with 5x equals 1. And then dividing both sides by 5, we're left over with our other answer of x equals 1/5. So our two answers are -2 and positive 1/5. Next example. So solving the following equation. We have z squared divided by 6 minus 3z over 2 minus 27 equals 0. So, looking at this, a lot of us do not like fractions. So let's go ahead and get rid of our fractions first. So to do that, I can multiply everything by the LCD. Fractions mean divide, so in order to get rid of fractions, I'm going to do the opposite, and I want to multiply everything by the LCD. Looking at our denominators, we have 6 and 2. In order to find my LCD, in order to find my least common denominator, would be 6. So we're going to multiply both sides of the equation by our LCD, which is 6. To get rid of our fractions. So distributing that 6 to every single term on both sides of our equation. 6 is the same thing as 6 over 1, if that helps you. So whenever you multiply straight across. So 6 times z squared will give us 6z squared all over 1 times 6, which will give us 6. Minus 6 times 3z will give us 18z all over 1 times 2, which will give us 2. Minus 6 times 27 will give us 162 over 1, which is just 162, equals 6 times 0, which is 0. So we didn't get rid of our fractions yet, but whenever we simplify, we will. So 6z squared divided by 6, our 6's cancel out. We are left with z squared minus 18z divided by 2. 18 divided by 2 is 9z minus 162 equals 0. So we now have it in factored form. We now have it in standard form. So we can go ahead and factor. Z squared minus 9z minus 162 equals 0. Our first step in factoring is our GCF. There is nothing that all three terms have in common, so no GCF. Our A value is 1, B is -9, and C is -162. So looking at this, we are looking for two numbers that can be multiplied together to give us A times C, 1 times -162, which is -162. And the same two numbers that could add together to give us -9, which is B. So 9 and -18. 9 times -18 is -162. 9 plus -18 is -9. So this satisfies both conditions. So good news, because our A value is 1, we can use our shortcut. And go straight to factors. So using the numbers in our blanks and our z variables. So z plus 9 and z minus 18, using the numbers in our blanks, will equal 0. So we now have it in factored form. So we can now set each factor equal to 0 and solve each one separately. So we have z plus 9 equals 0, and we have z minus 18 equals 0. So solving each one separately, we can, z plus 9 equals 0, we can subtract 9 from both sides and get z equals negative 9 as one answer. For z minus 18 equals 0, we can add 18 to both sides, and we are left with z equals positive 18 as our other answer. So our two solutions are z equals negative 9 and z equals positive 18. Next example, solve the following equation. 4t squared over 5 equals t over 5 plus 3 over 10. Again, we want to get rid of our fractions first. So we can multiply everything by the LCD. Looking at our denominators, we have 5 and 10. So our least common denominator could be 10. And again, we are going to distribute that to every single term on both sides of our equation. So we're going to multiply by our LCD to get rid of our fractions. Remember, if this helps you, you can write it as 10 over 1. So that way we multiply straight across, top times top, bottom times bottom. 10 times 4t squared will give us 40t squared, all over 1 times 5, which is 5, equals 10 times t, which is 10t, all over 1 times 5, which is 5, plus 10 times 3 will give us 30, all over 1 times 10, which is 10. We can now simplify. Each fraction to get rid of our radicals. So 40t squared divided by 5, 40 divided by 5 will give us 8t squared, equals 10t divided by 5 will give us 2t, plus 30 divided by 10 will give us 3. So we've got rid of our fractions, which is good. But now we need to leave it in standard form. Put it in standard form. Which remember is ax squared plus bx plus c equals 0. So I need to get it set equal to 0. So you can either move the 8t squared over, or you can move the 2t and the 3 over. Either way, you'll get the same answer. So subtracting 2t from both sides and subtracting 3 from both sides. We are left over with 8t squared minus 2t minus 3 equals 0. So it is now equal to 0. It is now in standard form. So we can now factor. So 8t squared minus 2t minus 3 equals 0. So our first step in factoring is GCF, which there's no GCF, nothing that all three terms have in common. So our a value is 8, b is negative 2, and our c value is negative 3. So we are looking for two numbers that multiply together to give us 8 times negative 3, which is negative 24. And the same two numbers to add together to give me b, which is negative 2. So negative 4 and positive 6. Negative 4 times positive 6 is negative 24. Negative 4 I'm sorry, this is the other way around. Positive 4, negative 6 is negative 24. 4 plus negative 6 will give us negative 2. So we now need to factor by grouping because a is not 1, so we cannot use our shortcut. So because a equals 1, we have to factor by grouping. So we are going to use the numbers in our blanks to split up that middle negative 2t term. So 8t squared Splitting up our negative 2t using the numbers in our blank. So plus 4t minus 6t minus 3 equals 0. We now have 4 terms. We can now group the first two, group the last two. So I'm going to bring this up here, writing the same thing. We have 8t squared plus 4t minus 6t minus 3 equals 0. So grouping the first two, grouping the last two. Looking at our first two terms, 8t squared plus 4t. I can factor or divide out 4t from both terms. And we are left over with 2t plus 1. Looking at our last two terms, I know I want 2t plus 1 to be left over. So I can factor out a negative 3 as our GCF. And we have 2t plus 1 left over equals 0. So they both have 2t plus 1 in common, so that'll be one factor. And taking out those 2t plus 1s, we're left over with 4t minus 3 equals 0. So we now have it in factored form. 2t plus 1 times 4t minus 3 equals 0. So setting each factor equal to 0, and we will be done. 2t plus 1 equals 0. I can subtract 1 from both sides. So 2t will equal negative 1. We can then divide both sides by positive 2. So t will equal negative 1/2 as our first answer. 4t minus 3 equals 0. I can add 3 to both sides and we get 4t equals 3. Divide both sides by 4. We will get our other answer of t equals 3 over 4. So our final answer is negative 1/2 and positive 3/4. All right, our next example asks us again to solve the following equation, y cubed equals 25y. So our first step in solving this equation is to put it into standard form. I need to get it set equal to 0. So we are going to subtract 25y from both sides. So we're left with y cubed minus 25y equals 0. So we want to put it in standard form, which is basically just set equal to 0. So now I have y cubed minus 25y equals 0. So now from here we can factor. Our first step in factoring is to find the GCF. Y cubed minus 25y, they both have a y in common. So I can factor or divide out a y from both terms. Taking out that y, we're left over with y squared minus 25 equals 0. So still trying to factor. I noticed that y squared minus 25y is subtracting 2 perfect squared. Y squared is y times y. 25 is a perfect square as 5 times 5. So I noticed this is a difference of perfect squares. So it helps us factor this one a little bit easier. So bringing down our y. So I know y squared is y times y. It's subtracting, so that means there's a difference. So it means that our signs are going to be different. One's positive, one's negative, and 25 is 5 times 5. So we easily factored this equation, and we're left with y times y plus 5 times y minus 5 equals 0. So going up here and setting each factor equal to 0. Y is our first factor, so y equals 0. Y plus 5 equals 0 is our next factor. And lastly, y minus 5 equals 0. Solving each one separately, we will get our 3 answers. Y equals 0 is done. That's already solved for us. Y plus 5 equals 0. We can subtract 5 from both sides, and we will get y equals negative 5. Lastly, y minus 5 equals 0. I can add 5 to both sides, and we will get y equals positive 5. So those are my three final answers, 0, -5, and +5. Notice my original problem was y cubed, so y to the third power. So that tells me I should have 3 answers, by the way. All right, next example, solving the following equation. Again, we have a cubed function, so we know we're going to have 3 answers. Our question is n cubed minus n equals 2n squared minus 2. Same thing as usual. We need to get this in standard form. We need to get this set equal to 0. So I want to move everything to one side. So let's subtract 2n squared from both sides. And let's add 2 to both sides to cancel out both of those and get it set equal to 0. Writing in order, I have n cubed minus 2n squared minus n plus 2 equals 0. So again, we put it in a standard form, which is set equal to 0. So now I have it in standard form, so now I can try to factor. Our first step in factoring, no matter what, is GCF. So looking at n cubed minus 2n squared minus n plus 2 equals 0. There's nothing that all the terms have in common, so no GCF. Looking this, we have 1, 2, 3, 4 terms. So we already have 4 terms, so we can go ahead and factor by grouping. So group the first 2, group the last 2. Looking at our first 2 terms, n cubed minus 2n squared. Looking at our GCF, they both have n squared in common. So I can factor or divide that out from both terms. And we're left over with n minus 2. Looking at our next 2 terms, negative n plus 2, taking out our GCF of negative 1. Taking out that negative 1, we're still left over with n minus 2 equals 0. So n squared times n minus 2 minus 1 times n minus 2 equals 0. We know we did it right so far because they both have n minus 2 in common, so that's going to come out front as a GCF. Taking out those n minus 2, we're left over with our other factor of n squared minus 1. So n minus 2 times n squared minus 1 equals 0. I'm just going to rewrite the same thing up top where I have more room. So n minus 2 times n squared minus 1 equals 0. Looking at this, I notice I have another difference of perfect squares here. So I can keep factoring it. So my main thing is whenever I see a squared, like n squared here, I need to look to see, can I factor it further? I have n squared minus 1. I see I'm subtracting 2 perfect squares. N squared is n times n, 1 is 1 times 1. So that means we can factor this yet again, factor it further. So bringing down our n minus 2, we're left over with our other 2 factors. So n squared is n times n. We are subtracting, so we're going to have different signs. So one's positive, one's negative. And our 1 is going to be 1 times 1. So we now have it completely factored. N minus 2 times n plus 1 times n minus 1 equals 0. So our last step is setting each factor equal to 0 and solving each one separately. So n minus 2 equals 0. I can add 2 to both sides, and we get that answer of n equals positive 2. N plus 1 equals 0. I can subtract 1 from both sides, and we will get n equals negative 1 for that answer. Lastly, n minus 1 equals 0. I can add 1 to both sides, and we get n equals positive 1 for that answer. It's n cubed, so we knew we were going to have 3 answers, which are 2, negative 1, and positive 1. Last example for this section. Solving the following equation. Negative 7 times n minus 12 plus m equals 13 times 7 minus m. Looking at this, there's a lot going on. So I want to start by simplifying this. I want to start by getting rid of the parentheses. So I'm going to distribute this negative 7 to both terms. And I want to distribute this positive 13 to both terms. So we are going to start by distributing. Negative 7 times m is negative 7m. Negative 7 times negative 12 is positive 84. Plus m equals 13 times 7, which is 91. 13 times negative m is negative 13m. So we distributed. Looks better, but we still have a lot going on. We have negative 7m plus 84 plus m equals 91 minus 13m. So let's continue to combine like terms. So let's get our m's together. So negative 7m plus 1m will give us negative 6m plus 84 equals 91 minus 13m. So getting better, but I still see I have m's on both sides. So I want to bring my m's to one side. I want to bring this negative 13m to the other side with our negative 6m. So I'm going to add 13m to both sides. So negative 6m plus 13m will give us 7m plus 84 equals 91. We're getting closer. I see that there's no m squared or no n cubed, nothing like that, just regular m. So I can solve this like a normal equation and continue to combine like terms. So let's move this 84 over here with this 91. We're going to subtract 84 from both sides. That'll leave us with 7m equals 91 minus 84, which is 7. So 7m equals 7. And lastly, getting m by itself, we can divide both sides by 7, and we will get m equals 1 as our final answer. This was m to the first power, so our first degree, so that tells me I should only have one answer. So this is all of Module 6 Homework 1 notes.